Hello, everyone. Good morning.
Morning.
Good morning.
Yeah, hope everyone had a nice weekend. Okay, yeah, new week. I think we will start a new chapter, right? But before that, let me explain why the grade of the first assignment has not been posted last week. I thought it was posted, but actually the TA has graded that, and but I need to confirm the score before the score posted in Blackboard. So I didn't know this function. So after several students sent me an email saying that they didn't get the score, so I just checked the Blackboard and I find this function. So if you find any question regarding your grading, uh, let me know or let TA know. But I think for the first assignment, it's not quite difficult to grade. But for the third one, maybe I posted yesterday. It's a programming, right? And some you need to have some demonstration there. So if you feel grading in the future is not very fair or it has some problems, just let me know, okay? So anyway, I think I posted assignment 3 even before the due date of assignment 2 because I want you to have more time to prepare because this is our first programming assignment, okay? And if some of you have already finished assignment 2 because assignment 2 is also not very difficult, okay? And you can start assignment 3 as early as possible. After that, I will post assignment 4. I think for assignment 4, I will also give you about maybe 2 weeks because it's a Wireshark assignment. It will ask you to use a Wireshark to test some traffic, some congestion, something. But before that, I plan to ask a TA to give you maybe half of lecture or one lecture about how to use Wireshark. Okay, that's a software we mentioned, but we didn't go to the detail quite well. So I will ask TA to give a tutorial about the software. Okay, then we can post the assignment 4. So I think that's already maybe half of the semester. Okay, and our lecture could be go to the chapter 3 and the chapter 3 or chapter 4 at that time before the end of the October. Okay, so that's the plan. So if you have any question regarding assignments, plan, or about the exam, okay, so for the exam as we planned, we can have it before the break. I will finalize the date and let you know. Okay, so as we discussed, it should be a take-home test because we don't want to have an online protocol. Okay, yeah, we don't want to have an online exam. So that's pretty. Any question before I start my lecture today about the assignment or the schedule plan? Okay, so if it sounds good, let me start my lecture today. So today we will start a new lecture, a new chapter, a new chapter. It's chapter 3, okay, transport layer. So I think this course, right, is from top to down. So after we finish the application layer, definitely we need to go to the next layer, right, transport layer. So still remember application layer, transport layer, network layer, right? Um, application, transport, network, and downstairs is a link, right? Physical layer and to the wire, right? So if you still remember the transport layer, I think we talked about last week UDP and TCP, right? So for this week, and maybe kind of one lecture next week, we will give more details about the UDP and TCP, especially TCP, right? How we can make a very reliable and we can guarantee the quality of the data or message transfer, right? So for this chapter's overview, we need to understand the principles behind transport layer service, multiplexing and demultiplexing, the reliable data transfer, flow control, and congestion control. Okay, we need to learn about Internet Transport Layer protocols, UDP, TCP, and TCP congestion control. I think you have almost got the idea about the UDP and TCP, what's the difference and what's the maybe similarity, right? But here we will go to the detail about the protocol itself, right? Detailing maybe about the, still remember HTTP, we have protocol format, right? So what about the UDP, TCP protocol format, right? Message format. We need to add something to the data, right, itself. So that's the general idea about this chapter. So and in detail, we need to learn our transport layer service, multiplexing and demultiplexing, and then go to UDP and TCP, some detail here. So first, let's see something about transport service and the protocols. Maybe some of you have a question. So we have application layer, we have a network layer. So why we need to have a transport layer, right? So UDP and TCP. What does this layer how does this layer plays an important role in the internet or in the networking, right? So definition is that transport layer or protocol or service provide a logical communication between application processes running on different hosts, right? You know the application processes, right? We use different port numbers, okay? And so here you can see that this is what we mentioned, the application layer, transport layer, network layer, data link, and the physical layer, right? To wire and to another, or wireless, right? To another host. And the transport protocols actions in end system, it has a sender and a receiver, right? So sender, it breaks the application message into segments, passes the segments to network layer, or the next layer, or down level layer, right? And the receivers reassemble segments into messages, passes to application layers, right? Still remember, we use flight, right? Landing, right? Taking off, and gating, ticketing, right? So that's just a procedure and reverse procedure, right? So it's some kind of similar. The transport protocol breaks the application messages, right? And receive and reassemble the messages sent to pass it to the application layer. So two transport protocols are available to internet application. One is TCP, one is UDP, right? We mentioned that many times. And we have also, I uploaded the, by the way, I uploaded the Python example code already into Blackboard. You can test and play by yourself. And for the assignment 3, similarly, it asks you to fill up some missing code lines there about how to use socket programming, right? We discussed last lecture. So that's the idea about the assignment anyway. So this is two commonly used protocols, TCP and UDP. Okay, so we will talk about detail later, but general speaking, you still remember for TCP, you have to establish the connections between different hosts, and TCP needs a specific IP and port number. It's point to point, but UDP, we will mention that later, but UDP is just you have a unique IP address, then just send it, right? So it doesn't point specific, right? Just use a one socket to everyone, to everything, to all, right? So the transport versus the network layer service and protocols, then yeah, this is a question I just asked. Maybe some of you curious about why we need to have a transport layer, right? Why we cannot use a network layer. It's fine, right? Why we need a transport layer? So we can use something like two families, right? As an example, so there are different kids, children in Anne's house sending letters to 12 kids in Bill's house, right? We have two families. We have different children, kids there, and you can think about the hosts as houses, right? You have two hosts, you have two houses there, and the processes is kids, right? The kids is the process is kids, right? So you can think about like this way. And for the application message is the letters in the envelopes that the kids need to send some message, some letters to the other houses kids, right? So transport protocol is like Anne and Bill who demultiplex or demux to in-house siblings, right? They need to take care of, they receive a lot of emails, right? Or mails here, right? Envelopes here. And they need to be in charge of receive the letters and pass the corresponding letters to envelopes to the correct kid there. Okay, so the network layer protocol is like a post office or postman, right? They are responsible for the delivering service, but for the transport protocol, it just break the message, right? And assemble the message and pass the message to specific application process. So I think this is a good example for you to understand what's the difference between the application layer and the network layer, because the transport layer is between them, right? So is that clear? I think this example is very clear to understand. And for the transport layer, is a logical communication between processes. It's a relies on and enhances network layer service, right? So if you don't have a transport layer, you can think about that the postman or postal service needs to specifically handle each envelope or letters to specific person, right? But they're not very efficient, right? They need to have some other people to handle. They just put all the envelopes or letters in the mailbox, right? Then there's some people to handle that, to deliver the mail to each kid, right? So you can think about transport layers function like this way, okay? So it can rely on enhances the network layer service. So here is the transport layer actions. You have sender and receiver, okay? And at the beginning, the sender passed the message. I think you have known this animation before, right? But let's just do it again. Maybe specific to the transport layer protocol, okay? Application layer passed the message to the transport layer, right? Transport layer add head, right? As we mentioned, add a header, right? So I remember last week, there was one student asking about what is if some bytes or bit loss, right? So we will specifically mention that in this chapter, but you need to put something in the application message. Otherwise, how you can identify there is no data loss, right? There is everything is happening correctly, right? Or in a good order, right? So you have to add something here. And the network layer also creates segments, okay? And it passes segment to the next layer to the IP address, to IP, right? Network IP, and go through a link and physical layer and go to the next host physical and the link layer, and then go to the IP receiver, right? Receive the segment from the IP, and they just check the header value, as I mentioned, right? So if we don't have the header value, how you can know that everything is no problem, right? So you have to add something there. It's kind of like a metadata, right? And it's we call it a header value or head data, right? So after that, it extracts application layer message and pass the multiplexed message up to the application through the socket. Okay, so that's a general process about the transport layer protocol or procedure, right? So the two principles of the internet transport protocols. So you can see here, the TCP is a transmission control protocol, right? We give it the definition before, but again, it's a reliable in order delivery. It has a congestion control, it has a flow control, it has connection setup, right? After connection setup, you can send and receive data. Before the connection established, you cannot do, right? But unlike UDP, right? UDP doesn't need to do that. UDP, the user datagram protocol, it's an unreliable, unordered delivery and no frills extension of best effort IP. Okay, the service are not available for UDP. The delay guarantee service are not available. I think this is for the transport protocol, right? Delay guarantee and bandwidth guarantee. So this is something even TCP cannot guarantee, right? Because this is something for the physical or link layer, right? Data link layer, right? So you cannot guarantee delay, but you can guarantee the reliable and in order delay. Otherwise, the TCP may report some problem or issue for you to do diagnostics, right? So to check. So that's the general principle of the transport layer protocols. And we can take a look at how these protocols duplex and multiplex and demultiplex the message. Okay, so let's see, this is figure showing the HTTP server, right? So HTTP server is based on, if you remember, it's based on the TCP, right? So it's a TCP based application. Okay, I think we mentioned that before. And you can see here, we have the HTTP server, the HTTP message, and the other HTTP, just divide the message, right, into different segments and put the header here. And I think it's similar to the previous animation, right? So it's similar. Let's just quickly go through that and send the message to the client. Okay. So, but the question that if we have two clients, right? If we have client one and client two, and we only have a one HTTP server, right? What will happen, and how to guarantee the message passes to the correct clients, right? So that's the question. How, maybe as a server, I have to know that which client send me which request and I respond which message or data, right? I have to have some management or scheme here, right? I cannot send the messages that's supposed to be sent to client one, but I send that to client two, right? That's not reasonable. So I have to make sure I send the correct or corresponding message to corresponding client. Okay, so that's a general idea. And the multiplexing and demultiplexing is an important component to send and receive the message to correct clients or server. Okay, so here we can see we have two processes in application or host server, right? And we have P3 and P4 in the client servers here. Okay. So the multiplexing at sender is a handle data from multiple sockets at transport headers. Later for the demultiplexing. So here's a definition, right? So multiplexing at sender. So this is a sender, right? So this is sender. We have the two processes in the application, and we have one process in the receiver per application, and here is process 4 for another receiver or another client, okay? So the multiplexing is just to handle the data from multiple sockets, right? Add the transport header, right? This header information will be used for the demultiplexing in the receiver side. Okay, so the demultiplexing at the receiver is uses header information to deliver receive the segment to the correct socket. You still remember in the example code we demonstrated, so you have to, once you receive the packet, it has the IP address and the specific port number, right? So you need to specify the user specify the port number to deliver the message to specific application process, right? So that's how port number plays the role. Okay, so how demultiplexing works? So the host receives the IP datagrams. So each datagram has a source IP address and destination IP address. Okay, it has both addresses, and each datagram carries one transport layer segment, and each segment has a source destination port number. Okay, I think that's you have already seen these things in the our last week's demonstration, right? So each segment has a source destination port number, right? And the host use the IP address and the port numbers to direct segments to appropriate socket. Yeah, and I think that's true, right? Just use the IP address and port number to direct segment to appropriate socket, right? In the socket programming, we have already know that, right? So this just emphasizes. So you can see here, it's a TCP and UDP segment format. And for each segment, there are 32 bits for the source port and the destination port, right? So the other is the other header information, and this is application data. So that's why we say that we need to add some headers to each segment, but this segment need to have some information about the source port number and destination port number, okay? And the host after receive the package, right, or packet, right, so they just use the destination port number to identify which socket they need to talk to, right? Um, okay, so the connectionless demultiplexing. I think this is something we slightly mentioned last week, but let's just recall that. So when creating a socket, you must specify host local port number. Remember last week we used a number 12000, right? We use that port number. So here is any port number is a larger number that will not have conflict with the current port number, right? So you just use the data gram socket function to create a new socket here. So the socket port number is 12534. And this function is provided by the Python module library, right? So here is something we have already seen last week. And when creating a datagram to send into UDP socket, you must specify the destination IP address and destination port. Right, this is something about the UDP socket programming. I think we have already mentioned that before. Okay, and when receiving the host, when receiving host receive, one host receives the UDP segment, right? Not one receiving host receives. One host receives UDP segment, it checks the destination port number in the segment. You receive the packets, right? And you check the destination port number and you direct the UDP segment to socket with that port number. Okay, so the IP UDP datagrams with the same destination and port number, but with a different source IP address or source port number will be directed to the same socket. This is what I emphasized and what I mentioned. So for UDP, as long as the receiver side, you have the same port number, you have the same IP address, right? Same destination, they will go into the same socket. Okay, you don't need to have, for example, I have two senders, right? Or even I have one senders have one sender have two port numbers. Even I have such situation, they send the data to the same destination port number with UDPs. Uh, it's still handling by the same socket. Okay, it's not distinguished, right? As long as the same destination, same port number, it will be handled by the same socket. So that's a very important point you need to remember here. So what's the difference, right? In detail, what's the difference between the UDP and the TCP? I will talk about TCP later, but this is something very important for the demultiplexing, right? For UDP, right? As I repeat again, just the same destination, same port number that will be handled by the same socket, okay, at the receiving side. Okay, so this is a connectionless demultiplexing. Connectionless means that UDP, right? You don't have to establish the connection. You just send the packet to the destination with the IP address and the port number, right? With the same one, you just handled by the same socket. Okay, so here is an example. This example will help you to understand how the demultiplexing will play with the UDP protocol. So you can see that you first use a new datagram socket, right? This is a new function to create a new socket for the P3, right? So let's say this is a server client one, right? This is a client two, this is a server, right? Let's say the client one, right? Create a socket corresponding to the process 3, okay, with the socket, with the port number 9157, okay? And this is another client, it creates a socket with a port number 5775, okay? Two different hosts, two different port numbers, okay? And I only create one socket with a one port number is a 6428 here, right? And what will happen? So we ask we first ask the server one, right? Oh, sorry, client one to send the message from the socket 9157 to the destination port 6428, right? So this is a one UDP send and this is one UDP receiver, right? We have demonstrated last week, right? This is something you already know, I think. If you don't remember, you can check the last week's lecture or just play the Python code I uploaded, okay? And okay, so this is a one send, right? You request and the server respond to you, right? From the port 6428 back to the 9157, right? So this is you know, one trip or travel for the request and response, right? Respond. And another side, we have I mean, we have server two, right? As client two. The client two also need to send the request and receive the responses, right? So what about the source port here and destination port here? So for the destination port, right, it's let's talk maybe first one, right? The first is a source port is 6428, right? And the destination port is 5775, right? This is for this send and receive, right? But for the underneath one, it's a source port is 5775, right? And destination port is 6428. So you can see that for the either the P3 or P4, they are using the same destination port here, right? Even they have the different source port. This source port is a 9857. This is a 5775, right? So even they have the different port numbers, but they have the same destination port, right? Or definitely they have the same IP address, right? Same destination, same data port. That means they will use the same socket. They will communicate or they will talk to the same socket under the UDP protocol, the connectionless demultiplexing. Okay, so that's what this example tells you, right? So same port number, same destination, they are using the same socket here. We only create one socket here, right? That's about UDP. You can see the scheme is kind of easy, right? You don't need to create a lot of a socket. You just create one socket with one specific port in um, this uh, server side and talk to the different process, to the different destination, to the different port numbers, right? Everything handling by one. So that's the point I emphasize here. So that's about UDP. So what about TCP, right? Maybe you have already got a feeling about that. For the TCP, you have to specify the pair of the sender receivers port and IP addresses, right? One by one, right? Maybe you have already got the feeling, but let's go to the detail here. So for the TCP, it's not just using the same destination IP and port number. It has to be paired because it has been connected before sending and receive, right? Connection means that the specific destination IP, specific source IP, specific source port, specific destination port, right? Those four numbers have been paired and establish a connection and point to point send and receive data before you close this connection, right? um, I think I remember last week one student asked, okay, so if you establish a connection, can you send a multiple package or message? Definitely, right? So the establish the connection, the purpose of establish the connection is to multiple times sending, receiving the data, right? But this is point to point. My point is that, I mean, this point means that the specific source IP, source port number to specific destination IP, destination port number. Okay, so this is demultiplexing is a receivers use all four values for tuple, right, to direct a segment to appropriate socket. So this is a pair of four values, okay, and this four value will give the idea how you send and receive the data based on the connection. So the server may support many simultaneous TCP sockets, each socket identified by its own four values, right? And each socket associated with a different connecting clients, right? With a different connecting clients, this client has determined the specific port IP address and the port numbers, right? You use four values to to decide the one connection. So that's the point here. Okay, let's see similar example. Okay, this is some similar example, but you can see that we have the different processes in server side. Okay, in last example, we only have one process, means one port in server side. But now we have P4, P5, P6. We have 3 processes in the server side, right? So for these multi-processes means that multi-ports and how we can handle the talk or communication with the different clients. That's how this example will demonstrate to you. And you can see here for the first TCP, after you establish connection, right, you send the message to the socket in the client side and the server side. So first, I think you send the request from the client one, right? So the source IP is the IP is this one, right? This is one's IP. Okay, let's say this is a server, right? Port is A9157, right? And the destination, sorry, source is this one. Sorry about that. Yeah, source is client one. Port is A9157. So this is a client's port. And destination port is B80, right? Because this is a HTTP server. So you remember HTTP server, the port number is 80, right? We showed that before. And after you receive the request, you reply, you respond with just reversed information, right? You reverse the source IP port and the destination IP and port, right? Just reversed values. So this is P1 to P4, right? But if we need to talk, the server needs to talk to the client too, right? And not or unlike UDP, because for the server side, the port number may not. This is the port number is a pair, right? Although they're both the 80, the both B80, right? But the source IP port are different. So they will use a different socket for this communication or talk to each other, right? So you can see this is use a different path, not unlike the UDP. Even they are using the same destination IP and port number, okay? And similarly, you can establish a connection between the P5 and the P3, right? Also, they have the same destination port number, but they have the different source IP and port number, okay? So I think for this side, it wants to demonstrate that with the same destination and IP, but different source IP and port, they will use a different socket. And this I think is for the even for send and receive the different direction, right? They also use a different socket. So that's the idea about using the 4 values to establish the connection and talk to specific socket, right? Yeah, with the TCP connection. So that means for the server side, if you are using the TCP protocols, you have to establish multiple sockets, right? So you can, from high level, you can think about idea. So what's the benefit from TCP? The benefit from TCP is that you can have a guaranteed, reliable, congestion controlled, flow controlled transport protocol, right? But the overhead would be, the performance, overhead would be high, performance would be kind of lower than UDP, because you can see here for the server side, you need to handle the different sockets, right? Different sockets means that you need to have the different number of processes, right? And that means sometimes you need to have a powerful server, having a multi-core system, right? You know the multi-core, right? For the server side, people are talking about, I have 48 cores, I have 556 cores, and maybe today I have 64 cores, right? Why we need to have such a large number of the cores? Here is one of the reasons, right? You have to establish different sockets, and different sockets talk to different destination, different kinds, right? Establishing the different sockets. So you have to have the powerful parallel and the multi-processing capability, right? But if you are using the UDP as we demonstrated, we only have a need to have a one socket. That's maybe enough to do that. So you can think about the UDP, the higher performance, lower overhead, but not very reliable. And with the destination, maybe it's just a single socket is enough to handle different source IP address or port numbers. But it's just inversed for the TCP situation. Okay. That's multiplexing and demultiplexing with different protocols based on the segment, datagram headers, field values, and the UDP is using the destination port number only, right? Destination plus destination port number only. And for the TCP demultiplexing using the four values here, source and destination IP address and the port numbers, right? So this is just a summary based on what we described. And the multiplexing and demultiplexing happen at all layers. But here we focus on the transport layer. Okay, that's the idea about the UDP TCP multiplexing and demultiplexing. Okay, so we can start a little bit about the connectionless transport protocol UDP. So for the UDP, I think for this subsection or sub chapter, most of the knowledge we have already covered. So we can do a quick through, right? So it's a Internet Transport Protocol. It's a best effort service. UDP segments may be lost, delivered out of order to application. We have already mentioned that several times. Just quickly go through that. And connectionless now means that we don't need to have a handshaking, right, between the UDP sender and receiver. Each UDP segment handled independently of others, right? And why they're UDP, I think we discussed this before. So it's no connection, performance is good, it's simple, right? And the no connection state as send and receive, small header message, right? You just put a destination IP, destination, a source IP, and the port numbers, some basic information there, right? There is no congestion control. The UDP can blast away as fast as desired, right? And it can function in the face of congestion. So good things and bad things, right? So I think you may already know that. And for UDP use, it's in streaming multimedia applications. It can tolerate loss, right? Loss of message, and it can use for the rate sensitive situations, right? Like streaming video, streaming audio, some rate sensitive case, right? And it has to guarantee a very fast throughput rate, right? So if a reliable transfer need over UDP, we may want to add a reliability at application layer, right? So even if UDP cannot, so I think this is a kind of good idea in computer system. So if the lower layer cannot help you to handle this, right, you have to add something in a upper layer to handle this. For example, if a UDP cannot guarantee some order, some reliability, right? So why we cannot add something in application layer? But it's not good because application people may not want to handle such a lower level thing. But if you want to have a good throughput, but during meantime, you may want to have some reliability, right? You can add something in the application layer like HTTP3. Okay, then also you can add something in the conjunction, the application layer for conjunction um, control. Okay, so let me check here. There is a question. Yes, so HTTP3 is, I think even for the HTTP um, 2, not very widely used as a HTTP 1.1, right? So still some time for people um, to be adapted to some new things, but I think using the TCP with HTTP 1.1 is is a commonly used in the internet. Okay, so but here just give you some idea that maybe in the future, if some layer cannot help you do something, you can think about a high layer to handle that. But this is not very convenient, right? People want to lower layer people to handle this for you. Like if I'm writing a program, I don't want to tune the performance. I want the computer architecture, right? GPU, CPU, DRAM to be as powerful as possible, right? I just write everything there, anything there, I just get a good performance. But it's not always true, right? If the architecture cannot satisfy you, maybe you need to fine tune your program or the performance to have good usage, right, or something, right? So this is just like a trade-off between the different layers. Okay. So this is a UDP request for comments 768 a long time ago. I think it's 40 years ago, right? Already 40 years ago. So long time ago when the TCP/IP. You remember the history of the internet development, right? So at the early stage of the internet development. And transportation layer UDP actions. So just to reduce that idea, the UDP send actions is pass application layer message and add the determine UDP segments and add the header values, right? And create the UDP segments after add the headers and pass the segment to IP. IP go through to this destination IP, and destination IP receiver action like receive the segment from IP and check UDP checksum header value, and the extra application layer message passed to the application through socket. So here is the thing we will talk about next lecture. What is the UDP checksum? So I think I received this question maybe about twice. A student asked if UDP cannot guarantee the reliable delivery, what happens if some bytes is wrong, right? If bytes cannot be received, if some bit flips, what would happen? So this is what we will discuss about UDP checksum. Okay, what we will add into the UDP header for checksum to make sure that the data, grams, or message you package you receive is complete, has no error, right? This is something we will talk about next lecture. Okay, so I think that's it for today. Any question?
So the transport layer is like an alternate method of getting from getting information from one location to another.
So I think I use a example as a beginning, right? As a two house example. So for delivery, right? It's like a postman to deliver the message, but the transport layer is like you assemble or disassemble the message to the segments to put some header value there and specifically give this message to some socket to some ports, right? It's like you have some people working in the building to help you receive the letter and and distribute the letter to different residents in the building. It's like this enhanced way. Yeah.
So a better analogy would be like calling UPS instead of having your friend bring an item to you.
Right, right. Yeah, but it will reduce the workload for the UPS, right? So if you can, you ask a UPS to deliver specific letter to your door, to your hand, right? But you can think about USPS, they don't deliver the letter to you, right? They just put in your mailbox, or maybe the mail center, and the mail center person belong to this building and distributed the mail to you, right? So you can reduce the UPS workload, right? But offload some workload to the building system or building management. So a protocol layer, transport layer, just like enhance the service to this building. Yeah.
Okay, thank you.
Thank you. Okay, so if you don't have any questions, that's it for today. Let's talk in Wednesday. So hope everyone have a good day. Okay, before that, another question, let me quickly check. Okay, this is just a note from S. Okay, thank you, S. Okay, have a good day, everyone. Bye-bye.